Hello everyone, I am Levihilda D. Carbos from Castillejos, Zambales. I work as a senior high school teacher at Castillejos National High School. I love teaching because it gives me joy and excitement meeting learners in different parts of the country. So our topic for today is statistics and probability. In my class, I work with wonderful enthusiasm and positivity. I am interested in many different topics and I'm happy to focus on my learners' goals. So this is an introduction on data management in statistics and probability. Let us first give an emphasis on our lesson objectives. So the first one is for you to understand different ways of gathering data, organize our data, and construct tables and charts for data. Before we proceed, let us first discuss what is data management. If you have an idea of what is a data management, kindly post your comments on the comment section box. So we can see if there is a similarity with the definition that I will be giving right now. Now let us define what is data management. So data management is the process of ingesting, storing, organizing, and maintaining data created and collected by an organization. Effective data management is a crucial piece of developing the IT systems that run business applications and provide analytical information to help drive operational decision making and strategic planning by corporate executives, business managers, and other end users. The data management process includes a combination of different functions that collectively aim to make sure that the data in corporate system is accurate, available, and accessible. Most of the required work is done by IT and data management teams. But business users typically also participate in some parts of the process to ensure that the data meets their needs and to get them on board with the policies governing its use. But why is data management important? Again, kindly write your answers in the comment section. So using data matching to spot commonalities at scale. In today's world, we always ask why data management is important. Hundreds of hospitals are testing and treating people for coronavirus. If you had just two hospitals, data comparisons between them would be relatively easy. But once you get to 50, 100, or more data sets, the data becomes impossible to compare manually. Data matching can help. Data matching identifies what is common among different data sets. In this example, what's common among them might be patients who visited more than one of the hospitals. Using data or data matching can also show that one data set contains details about 80% of the patients in the other data sets. That indicates this one data set might be a good place to start. You can use that data set to derive inferences and use the other datasets to validate the hypothesis. Coronavirus is teaching people the importance of trusting in data to make the best decisions. I believe we'll see countries that do this really well and bend the curve. Countries that do not do this as well or use data incorrectly are likely to be less successful at bending the curve. So the answer to the question is that it increases productivity. It increases cost efficiency, operational nimbleness, security risk, reduced data loss, and accurate decisions. For productivity, with good data management, your company will be more organized and productive. Students or employees will have an easier time finding, understanding, and relaying information. It is cost efficient because data management can help your organization or your group, if you are doing a particular or a specific project, avoid unnecessary extra costs such as unneeded duplication. When data is easily accessible, you won't have to worry about employees conducting the same research over and over again. Another importance of data management is operational nimbleness. Great data management makes it easy for companies or for groups or for projects to respond quickly to the world around them. This means companies can respond efficiently to market changes and react appropriately to competitors. Security risk. Proper data management helps ensure that your information stays secure and never ends up in the wrong hands. A strong data management system will help protect your information from theft and attacks. Another one is to reduce data loss. With a data management plan in place, you greatly reduce the risk of losing vital company information, and it also ensures your important information is backed up and retrievable in case something happens to the original copies. And the last one is accurate decisions. So proper data handling ensures accurate management of important data. In collection of data, we have to note that it is important that the researcher knows what is needed, where, and how to get the data. Data needed in research may be collected using any of the following methods that I will be introducing today. So the first one is the interview method. The interview method is the method by which data is obtained through oral exchange of questions and answers by the researcher and the respondents. This method is taxing and time-consuming, but it proves the flexibility of making follow-ups on the answers of the respondents. The next one is the questionnaire method. The questionnaire method is the method where a set of questions provided by the researcher and the data is provided by the respondents by writing the responses to the items in the questionnaire. Questionnaires may also be sent through emails and other form of technology for a wider coverage. Another one is the document method. So it is the method where researcher avails of information gathered and is stored by individuals or institutions, whether private or government, made available to researchers. An example of a document method is whenever you try to get to profile your students who are enrolled in a particular school, you want to ask them and or provide a birth certificate coming from the Philippine Statistics Authority. We also have what we call the observation method. So this method is the method where the data is acquired and recorded through direct observation by the researcher on an actual situation. And take note that this type of gathering of information is relatively expensive. So where do you do this? You do this you are actually doing this in your science classes during laboratory experiments. The last one is the experiment method. It is the method where data is also gathered by the researcher himself, just like in the observation method. However, the researcher is allowed to make manipulation as required. It is time consuming, and again, it is also expensive. So these are the data needed in the research may be collected, that may be collected. In data collection, response rate is a very important aspect. A low response rate may affect the validity of the conclusion to be made. Usually, the questionnaire method results in low response rate. So the following are the different ways of presenting data gathered. We have what we call the textual form. Textual form is a data is exposed through printed or spoken words such as printed or oral media. That's number one. We also have the second one, which is the graphical form. So these are some examples of the graphical form. So graphical form is where data is organized and presented through the use of various graphs. It facilitates analyzing, summarizing, and understanding voluminous set of data. So as stated here, these are the different types of graph. The line graph, pictograph, bar graph, histogram, pie graph, pictograph, cartograph, dot graph, stem and leaf display, and box and whiskers. The third one is the tabular form. This is where data are arrayed in rows and columns. So these are now, as you can see, all the data is in array and in rows and columns. A tool may be used to organize data set. So one tool for organizing a data set is what we call the stem and leaf display. We use stem and leaf display. So the data set, when using stem and leaf display, so this raw data is a number of kilowatt hour of electricity consumed by 20 households in a community. The data set is separated into leading digits known as the stems. Okay, so this is now the data sets using the stem and leaf display. Before the stem and leaf display can be set up, it is important that the data are arranged in rank order from the smallest to the largest. So the data are presented in kilowatt hour of electricity consumed by 20 households in a community in order, as you can see in this table. Okay, or as illustrated in this table. So we have the lowest value is 156, next is 169, and the largest value is 2,438. Okay, so this is how, so this is now the stem, and this, and under these columns is the leaf, wherein 1 unit is equals to number 1, or 1 item. So when the data is set has a large number of observation, the stem and leaf display, take note of this, that it may not be the best way of presenting data. Stem and leaf can still be used. However, data must be based on the frequency distribution of the given data. Large numbers of observation are usually presented using a frequency distribution, which is a summary table where data are arranged into groupings. So let's have an example of the on how to set up a frequency distribution on a step-by-step process. So we want to illustrate the final scores of a group of 45 grade 11 students in a school where it has 96 as the highest and 52 as the lowest scores. So these are the steps. Let's just start with the step 1. Okay, following this instruction should be done. So number 1, determine the number of class intervals or class groupings. The class intervals is a set of numbers defined by the lower and the upper limits of a class relative to the class size. So in general, the number of classes should be between 5 and 15, depending on the number of observations. It can be computed by the Sturgis formula given below. And the number of class interval is equals to 1 plus the constant value 3.322 multiplied to logarithm of n, where n is the total number of values. So this is the formula given by the Sturgis formula. So we will be using that. We will further explain the Sturgis formula later. So step 2 is to determine the width of the class interval, also known as the class size. The range of observation is the difference between the highest value and the smallest observation or the lowest value of the observed variable. So the class size is the quotient of the range and the number of desired class groupings. The width is normally rounded up when it is an integer and it should be rounded up to the next whole number. Okay, so that is for step 2. Determine the width of the class interval, or also known as the class size. So in the next step, which is step 3, we are now ready to apply the answers from step 1 and step 2, which is the number of class interval approximately equal to 7.49193 or approximately 7. And for step 2, we got the class size dividing the value of the range to the class interval 7. Since it is an integer, we should round it up and the value we got is 7. So for step 3, we have to establish the class limits. Okay, so since we have the values, the lowest value of the class is 52, equivalent to 52, and the highest value is 96, we will start with 52. In step 1, we were able to get the class interval of 7. So we'll start with the lowest value, which is 52, 53, 54, 55, 56, 57, and 58. As you can see, we ended with the number 58 because of the class interval of 7 is applied. Alright, so we have now the frequency distribution with its class boundaries. The class limits should be defined to include all observations in the dataset. Normally, the lowest score may be used as the lower limit of the first class interval. So that's what we did with the first class interval. So we used the lowest. We started initially with the lowest value. In step 4, we are going to define the class boundaries of each class interval to avoid overlapping. So the class boundary is composed of the lower class boundary. This is the lower class boundary and the upper class boundary. It is a number halfway between okay. So this is the number halfway between the upper class limit and of one class. For this, the first class, this is the second class and the third class, and the lower limit of the second class interval. So we have done that already. Define the class boundaries of each class interval to avoid overlapping. And then for step 5 and 6, for step 5, we have to tally the observations to get the frequency of each class interval. And for step 6, we have to determine or establish the class limits, wherein we follow this formula. Class mark is equals to lower plus upper limits divided by 2. So we get the value of the frequency or the class mark, which is equals to 55. Now, a frequency distribution can be presented graphically using any of the following. Okay, for graphical presentation, we have what we call the frequency polygon. So this is now our raw data. This is our raw data. And for the graphical presentation of a frequency polygon is shown on the right side. Okay. So frequency polygon is a line graph where the frequency of each class interval is plotted against the corresponding class mark. So since we have 55, 62, 69, 76, 83, 90, and 97. So those are the values of class mark. The horizontal axis contains the class marks, while the vertical axis represents the frequency. Okay, so these are the class marks, and this one represents the frequency. So we call this the graphical presentation for a frequency polygon. Okay, class mark. The next one is what we call the histogram. Again, we use the same data. So we call this the histogram. Histogram is a graph where, as you can see, there are rectangular bars are used to present the frequency distribution. And the horizontal axis contains the class boundaries, while the vertical axis contains the frequencies. Another graphical presentation is the cumulative frequency distribution. So what does a cumulative frequency distribution do? Okay? It provides the total frequencies less than or greater than a particular value in the datasets. So there are two types of cumulative frequencies, the greater than and the less than cumulative frequency. The less than cumulative frequency columns contains the accumulated sum of frequencies of each class interval that is less than its corresponding upper class boundary, while the greater than cumulative frequency is one where the accumulated sum of frequencies is greater than the corresponding lower class boundaries. I'll show how less than or greater than cumulative frequencies are done later in this topic discussion. So as you can see in the graph, a line graph is presenting the cumulative frequencies distribution. We call this an ogive. So we have two types of ogive, the less than cumulative frequency distribution or the less than ogive, and the greater than cumulative frequency distribution is called the greater than ogive. So this is a representation of the greater than ogive. As you can see here, this should be less than ogive. It should be in ascending order, and the less than cumulative frequency ogive should be in descending. You can see it visually in a descending values. Now, to get the less than cumulative frequency, using this frequency distribution table, okay, the less than cumulative frequency, we are to add the frequency cumulatively starting from the frequency of the lowest class interval, which is number 6, and then add the frequency cumulative starting from the frequency of the lowest class interval, and consequently get the greater than cumulative frequency and add cumulatively starting from the frequency of the highest. So we have the highest class interval, which is equals to 45. So how do we do that? So let's start with the less than cumulative frequency. So the lowest cumulative frequency is 6. We add the next class frequency, which is 2. So we get the value of 8, and then 8. Less than cumulative frequency, we add the next frequency, which is equivalent to 7. So we get the result of 15, and until such time that we get the highest value of the less than cumulative frequency, which is equivalent to 45. So for less than cumulative frequency, we are to add. But conversely, with greater than cumulative frequency, we are to subtract the highest value from the lowest value. So 45 minus 6 is equals to 39. 39 subtracted to 2 is equals to 37. 37 subtracted to 7 is equals to 30, until such time we get the same value of the last class interval equivalent to number 2. So aside from the frequency distribution, there are two other measures that can be used for the analysis of data sets. These are the relative frequency and percentage frequency distributions. The names imply that the primary interest to look into the share of each frequency relative to the total frequency. These are normally used when comparing two sets of data, even if the number of observations in the two data sets is different. So to get the relative frequency, we simply divide the frequency of each class by the total frequency. So this is the total frequency. We divide that and we get a value of 0.13. So 6 divided by 45 is equal to 0.13, and the result of 0.13 is expressed as a proportion that is less than 1. When multiplied by 100, it yields a result expressed in percent, which is 13.33% for the first class. So this is known as the percentage frequency distribution. Since we have the frequency percentage, we now call the frequency distribution as percentage frequency distribution. Without the relative frequency and percentage frequency, we call that the cumulative frequencies. If we remove the less than and the greater than cumulative frequency, we simply call the raw data or the distribution table as a frequency distribution table. I hope everyone follows uh, what is the differences between the distribution tables that was introduced. So these are normally used when comparing two sets of data, even if the number of observation in the two sets is different. Okay? So let's have some exercises or something to chew on. So we have here, in a frequency distribution, the class marks of the class intervals are 10, 15, 20, 25, and 30 respectively. I would like you to set up the distribution in tabular form and supply the missing entries. So I'll give you 10 minutes for this to finish. You may follow the step-by-step process on how to set up a frequency distribution table to get the missing entries. Okay, I hope everybody is done answering the first exercise. So let us check your answers. So class limits for item number 1, it's 8 to 12. Class boundaries, 7.5 to 12.5. Class mark is 10. And the class size is 5. Okay, so these are the correct answers. How many got a perfect score? Okay, I hope everybody got a perfect score. So let's have another exercise. Problem solving. The Sure Clean restaurant has the following income in pesos for a particular day from selling lunch meals. So from these data sets, I want you to, number 1, construct a frequency distribution using a class size of 20. Number 2, draw a histogram of the frequency distribution. Number 3, draw the less than ogive for the distribution. And number 4, construct the relative frequency distribution. You may submit your answers in Google Classroom. I'll give you 10 minutes to finish this part. Okay. Another problem solving is the latest scores of the students Maginhawa High School who took a science test are listed below. So again, from this raw data, I want you to construct a frequency distribution using a class size of 10. Draw a histogram of the frequency distribution table and draw the less than and the greater than ogive for the distribution in the same figure. So this will be another exercise for you. So you may submit your answers again in the Google Classroom. And for the last exercise, I want you to complete the following table. So I want you to observe carefully, especially on the part of the lower and the upper limit, because this upper and lower limit are not arranged in order. So you have to do that on your own to get the values of the missing entries. I'll give you 10 minutes to finish this and submit it to the Google Classroom. Now for your homework, I want you to answer these questions. Which method of gathering data is best for the following situations? So we have 10 items. And then I want you to group yourselves into 10 and determine the class mark, the class boundaries, cumulative frequency, or the missing entries of this uh, percentage distribution table. Another group work is a stem and leaf display, which represents weights in kilograms of a sample of 30 respondents. The tens digits are the stems, while the units digits are the leaves. So based on the data provided, do the following. 1. Construct a frequency distribution and a relative frequency distribution. And number 2, answer which graph is best for presenting the weights. Explain your answer. At least 1 to 2 sentences will do. Now you are ready to have your assessment. Okay, do this. The following frequency table shows the battery life of differently battery brands. So which of the following range of numbers shows the highest frequency and the lowest frequency? What can you say about the battery? Explain your answer. Okay. So the following shows the ages of participants in a chess tournament. In the given frequency table, there were errors found. What are these errors? I want you to please justify your. So let's call it a day. This is the end of our lesson for today. Thank you for listening and hope you learned a lot today. And you may be able to apply this in the future. Thank you very much. See you next meeting.